Cool. So, yeah, a couple admin things right at the start here, just to kind of set the stage for what we're going to do and how we're going to go about it and everything like that. So, I think as I mentioned at the end of last lecture, and certainly on the tutorial on Friday, yeah, congratulations, you figured out how to do TFL. So now we're going to move on to first order logic. And to be really honest, kind of everything we're going to do from here on out is going to center upon FOL. So more specifically, the next 3 weeks, we're going to just get used to the language. So we're going to work on its grammar, work on symbolization. That'll be for this week and next week. And then in week 6, or lecture 6, we'll talk about valuations, or the equivalent of valuations, for FOL sentences. Strictly speaking, they're not going to be valuations because we don't have atoms anymore. Instead, we're going to get a replacement notion, which we'll call interpretations. But more on that in a couple weeks. That will set us up for week 7, where we'll have a review. Week 8, we all have an exam. Hooray! And then in the second half of the course, what we're going to do is actually look at some of the philosophical consequences of first-order logic. Because just to kind of spoil things, first-order logic is what's often called classical logic. So this is the kind of approach that is standardly assumed to be the case. Sorry, don't worry about it. Whatever. And one of the things that we're going to get, or some of the philosophical upshots we're going to get, will stem from some choices we're going to make about how the formalism works. So, again, the next 3 weeks is us learning the formalism, learning the actual logical system, and then in the second half of the course, we'll be thinking, cool, now that we've got the logical system, what the hell does this tell us about philosophy? So that's the plan. I just want to go ahead and get that out. But of course, for all of that, we have to learn what the hell FOL is. So that's what the plan is for today. I'm going to start by talking to you about why we want to use it, what its value is, and giving you a very basic breakdown of the core constituent parts. The deep dark core is terms and predicates. From there, we're going to get quantifiers, which will let us talk about multiple things at one go. And some domains, always nice to have a typo in the title slide. Domains, I don't know what that is. It's domains, I'm sorry. Once we have the kind of basic building blocks, we'll talk through some fundamental first-order logic symbolizations. So looking at some sentences with one quantifier, I'll talk you through 4 particular symbolizations that are extremely useful. Basically, if we know how to do those, you'll know how to do almost all of the symbolizing you'll really need to do. And if we have time at the end, we'll talk about sentences featuring multiple quantifiers and relations. In particular, we'll talk about everybody loves somebody, which is an amazing sentence, and we can actually tease some things out once we have the machinery in play. So that's the plan. As always, stop me if you have questions. We're going to go reasonably quickly, because, again, I hope, please, God, I hope you have read the book on this case. But if you have questions or things don't make sense, you know the drill by now, right? This is the 4th iteration. We're figuring it out. Cool. So let's talk about terms and predicates. And let's actually talk about an argument that is very similar to one we've looked at before. So, premise 1, Socrates is human. Premise 2, all humans are mortal. Conclusion, Socrates is mortal. Clearly a valid argument. If you don't like this one, just replace mortal with a caret, and this will look terribly familiar. Right? But if we think about how we would symbolize this in TFL, we have a problem. So here's a way to symbolize it into TFL. We've got our symbolization key, and I've symbolized it up. And of course, this is not going to be valid in TFL. These 2 sentences do not tautologically entail the sentence S. We can come up with an easy table, right, that'll make the top 2 true and the bottom one false. Hey, come on in. So TFL doesn't let us capture the argument. It doesn't let us get the validity here. And that's bad, right? It's not earth-shattering. It just shows us that, hey, TFL is an instrument. It's not necessarily precision-tuned for every problem. So what we want to do is fine-tune things. Let's make our machinery better. And that's going to be the move. We're going to go from TFL to first-order logic, and it's going to let us capture the argument. So here's how we would symbolize the argument in FOL. Right? We'll have our first premise as, right, it's going to have a predicate, which is human. There'll be a name that has a particular individual, Socrates. So we can say HA, Socrates is human. We'll have a quantifier, more on these in a second, which basically lets us say, hey, for anything in the domain, if it's an H, then it's an M. And then because we know that Socrates is an H, we know that Socrates is an M. Don't freak out, it's okay. Right? So here's what the trick is. And here's how we're going to be able to do it. Is again, I think I made this joke on Friday, but it's one I always come back to. We basically have to split the atom. Right? If you go back and look here, we can't have any subsentential structure. We basically just hit the block Lego that is the atomic sentence, and we can't say anything about its parts. But if we have these sorts of structures, we have subsentential parts. We have terms to pick out particular individuals. We have a name for Socrates, so we can peg him. And then we also have particular predicates that he satisfies. He's a man. He is mortal. He's human, etc., etc. By having subsentential structure, we're able to track things better. We have more expressive power. Before we even go on, does the kind of point about subsentential structure make sense? Slightly confused, maybe. So let's think about it in terms of English, right? In English, to go back to the argument in English, right, we have words, individual words. We have a name for Socrates, and we have the is and human. So we have a verb, a noun, and then something like an adjective. Or a general noun in this case, but it's an adjective effectively. So these subsentential parts lets us build up complexes that are sentences. And the meaning of the sentence is going to be partially determined by the meaning of each of the parts. Natural language works like this. You have things that are below the level of just pure sentences. You have names, you have predicates, you have verbs, etc. TFL ain't got none of those. It's just got atoms. It's just got blank sentences. It doesn't have any structure to the sentence. And that's why TFL doesn't let us get this argument. So what we're trying to do is move to a new formal language, which has something like the subsentential structure that English or Dutch or German has, where we'll have things like names and we'll have things that are kind of like verbs. That's the big gain. Of course, the problem with that big gain is that the grammar becomes more complex. Just think about how easy the grammar for TFL was versus how fun the grammar for English is. Right? So FOL is still going to have a very rigid structure. It's still going to have a very, very minimal amount of ways to build sentences and things like this. But it's got more complexity than TFL does. But that's okay. So here's what FOL is made up of. It's got 6 kinds of symbols. There are 2 types of terms. There are names and there are variables. We will express names using lowercase letters A through R. Similarly, variables, which function very similar to terms, very similar to names, we'll use S through Z. Note for both of these, we can have subscripts if we want to, if we need them. It'll be pretty rare, but it's an option we have if we want to. So those are terms. Terms effectively help us pick out individual objects. Right? The clue is literally in the name. Right? More on how exactly variables work in a second. Along with those two, we'll have predicates. Predicates we express with capital letters. Now, predicates aren't sentences. They're things like is a man, or is a horse, is a carrot, is tall, is Dutch, etc., etc. It's a kind of property that needs to be stuck to an object to then give you a full sentence. So you will never, ever, ever see a predicate by itself. It will always have at least one term stuck to it, either a name or a variable. Because again, think of the comparison in English. If I just say, is a horse, I haven't given you a full sentence. I need to fill in a subject there. I might be able to get away with it in everyday English because there's a suppressed subject. We know who we were talking about, right? But again, grammatically, it's actually there, even if it's suppressed. This predicate plus term, that's going to be our new atom. That's going to be the fundamental unit of our language. It's always going to be a predicate and a term. Now, the term might be a name, and that will be the simplest one, or it might be a variable, and then we'll have to have something else. But that's our new replacement. The nice thing is, we'll also just inherit the connectives. They behave exactly like they did before. They're still truth functional. They behave exactly like they did in TFL. So negation flips the truth value. Conjunction requires the things on both sides to be true. Disjunction, at least one. Conditionals only false if the antecedent's true and consequence false. And the biconditional just says, hey, they both have the same truth value. Again, just like we had before. We have brackets. They do the same thing as they did before. Cool. The last thing are these. The backwards Z and the upside down A. These are quantifiers. And these are ways to allow us to talk about things without actually directly referring to them. So we can say things like, some of the people in this room are taller than 1.5 meters. In fact, I'm pretty sure maybe everybody in this room? Maybe. Right. So some, at least one. That's what the existential says. It gives us a way to have that kind of some talk. Meanwhile, the universal, the upside down A, is the way I can say everybody or all. Everyone in this room is taller than a meter. And again, note what we're doing there is I'm not using a name. It's not like there is someone who's everyone. Instead, I'm quantifying over all of you, and myself too. That's what the quantifier does. It gives us a way to kind of pick out everything without actually having to say, So we'll talk more about how these go. I just want to flag up the basic building blocks. So again, this is going to be our new fundamental unit. It's always a predicate and a term. The terms can either be names or variables. Yeah?
Is it correct to think that the quantifier of all or some, says something about the terms? So if I use the quantifier for the universal, I mean all the possible terms?
Kind of. Yeah. Strictly speaking, when we'll talk about this in 4 or 5 slides, it's not necessarily about the terms, but it's about the things the terms are named for. Because there might be things that we're going to talk about we don't necessarily have names for. Right? So I might want to say something about every human who ever existed and will ever exist. There's a shitload of them who don't have names yet.
Yeah.
Right? But I can still talk about them. They're all mortal. Right? So that's the kind of thing. There's a subtle difference because we don't have a term for them yet. We'll come to it. Good. Okay. So That's going to be the big building block. We've replaced atoms with these predicate plus terms. And that's nice, because if we go back, that's exactly what we had in our reconstructed argument. We have a predicate and a term for Socrates. We have two predicates and a quantifier attached to the variable that's linked to both of those predicates. And then again, we have a predicate and a name. Always a predicate and a term. Never see a predicate by itself. Okay, so let's talk about each of these in turn. Oh, crap, I forgot. Do we want to go for a bit and take a break, or do we want to push through and end a little bit early? What would be? I totally forgot to ask earlier. Break? Why don't we'll go till about 11:30, so say 30-ish more minutes, and we'll gauge the room. How's that? It's basically the best kind of solution. We'll just push it off. Okay. So I want to talk about each one of these in turn. Well, I'm not going to talk about the connectives. I'm not going to talk about the brackets, because those work just like what we did before. Cool, we're done. Okay. I want to talk about names, variables, predicates, and quantifiers, because I think getting those will really help us figure out how the language works. So let's talk about terms in English. So remember, variables and names are both types of terms. So in English, there are two types of terms. There's singular terms and general terms. Singular terms are words or phrases that are intended to refer or denote a specific entity. Contrast that with general terms, which pick out something like types or kinds. So we might have Mira is a singular term. It's intended to pick out a particular dog, my dog. Contrast that with dog, which is picking out something like a kind or type. Nathan versus teacher. Socrates versus human, or Socrates versus Greek. Again, what's the difference? The singular terms are all designed to get us to one particular object. The general term picks out something like a class or a group or a type of object. But when we think about singular terms, there's actually two, or at least two types. There's more, but there's at least two. One of them are proper names. And these seem to kind of pick out an entity without really building in any kind of descriptive content. The fact that my dog's name is Mira doesn't really tell you much about her. You don't know what color she is. You don't know what kind of breed she is. You do if you remember she was in some of the slides way back in lecture 1. Okay. But the fact that you know the name doesn't actually give you any kind of description or substantive qualities of the object. But it still works. You can still talk about my dog Mira because you know her name. Contrast that with definite descriptions. So proper names, you get to the object without really much descriptive content. A definite description is something that you get to a single object because it's the one and only thing that satisfies that description. The tallest person in the room. That will pick somebody out. Exactly who, I'm not sure. And we can talk about that person. They're going to be taller than me, for example, because I'm not very tall. Again, note, we don't even need to know who the referent is, but just because of the way the description works, we know some things about them. So both of these get us to a single object, one of them through a kind of direct path with no real qualities about the thing. A definite description gets us to the object because of the qualities it has. Yeah? Again, a nice contrast class here. Socrates versus the teacher of Plato. Definite description gets us to this guy. This term gets us to that same guy. Cool. Okay. Now, in first order logic, the thing that we'll call names, which we express through lowercase letters a through r with subscripts, they function like English proper names. That is, They're just tags for objects. But they're tags for objects with some qualifications. One qualification is there's no ambiguity. Each name picks out exactly one object. So I think I know like 3 different people named Tim. Right? That will never happen in FOL. You never have one name that potentially picks up multiple things. There's no ambiguity. We have one name for every object. If we've got a name, we know that it picks out something in the domain. No, we could have multiple names for the same object. But that's okay. If I've got a name, I know it gets me to something. Let me restate that. If I have a name, I know it gets me to something. So what this means is that for our language, there are no empty names. For example, consider Santa Claus. I don't want to shatter anybody's hopes and dreams, but Santa doesn't exist. Right? I know. Shit. I've been lied to. So think about the name Santa. Right? Santa's an empty name. It purports to refer to a particular object, but fails. In first-order logic, Santa wouldn't work. If you have a name, it's guaranteed to get you to something. There are no names like that. So note, though, this says whenever you have a name, it's guaranteed to get you to an object. That doesn't mean that every object is guaranteed to have a name. There might be things like the future people that we want to talk about, but we don't have names for. But if we have a name in our language, it's got to get us to something. We maybe don't know which one it is, but we know that it gets us to something. Okay. So when we construct a first-order logic symbolization key, what we'll do for any names that are relevant, we'll say what object it is that that name picks out. So for example, I might have A for Socrates, little m for Mira, little m1 for Mira if I wanted to have multiple names for her for some reason, right? Or little n for Nathan. And again, what are these? These are terms, singular terms that take you to the particular object. Cool. So far, so good with names. I mean, this is the gentle beginning bit. Variables are a bit like names. We express them with lowercase s through z. We can use subscripts if we need to. Right? Now, variables aren't names. They don't pick out objects. They're a bit more like pronouns. In that what they are effectively gaps. Gaps that we can replace with objects or with names. And they're a way for us to label the gaps. To say, hey, I want to talk about the thing that's in this gap and that's also over here. So for example, I can say something like X loves Y, but Y doesn't love X. What am I trying to do? I'm trying to say, hey, there's an object I can plug in for here and here. It's the same thing replacing the X in both cases, and it will be the same thing replacing the Y in both cases. He loves her, but she doesn't love him. I want those pronouns to refer to the same things. I want the her and she and the he and him to get me to the same objects in both cases. Did people do algebra? Have we done algebra before? You sort of remember like when you were solving for x, and x could be a lot of different numbers. That's the same thing here, right? X here is standing in for a variable. We can replace it with any kind of object we want. And the difference occurrences are just to make sure you always replace it with the very same object. All the x's are going to be replaced with Socrates. All the y's with Mira. Well, okay, etc., etc., etc. When constructing an FOL symbolization key, you don't have to tell me what the variables stand for, because they don't stand for nothing. They don't stand for anything. They're ways for us to label gaps. If you want to think about it another way, they kind of stand for nothing and every entity. Every in the sense that we theoretically could replace them with anything we're talking about, and nothing because, well, they're not really a way for us to get to any object. They're just a way for us to label gaps. So here's the third big basic thing. Predicates. I already said some things about them, right? Predicates are parts of language that we might think of as describing something like properties. So like, is in the logic class, or a dog slobbered on, is human, is taller than Nathan. Note, all of these constructions have gaps. We have to fill in a noun, a term. So, Tim is in the logic class. Nathan is in the logic class. We fill in that gap with a name, or maybe a definite description. Predicates link up with singular terms to form sentences. So we take is human, we plug in is Socrates to fill the gap, and we get a full sentence. Socrates is human. It's the same thing here. Predicates in FOL have gaps. Only once the gap is filled do we get something approximating a sentence. This is half of an atom. We need the other half. The other half will be some kind of term, be it a name or a variable. FOL predicates we express through capitals A through Z. We can use subscripts just like always if we need them. Right. And our symbolization key is basically going to tell us what it is it expresses. So I might have like, oh, capital H is the way for me to say, is human. Or capital T is the way for me to say, woke up at 3:30 a.m. Or T subscript 1 is a terminator. So note again, when we write these down, we leave the space to basically indicate this is where the term would fill in. Questions so far? How are we feeling about names and variables and predicates? So far, so good? Let's see. We need to get a grip on these by thinking about how to build FOL sentences by looking at how the terms and predicates go together. So here's our sample symbolization key. It uses all the various examples we've gotten through so far. And we might, take the predicate H and the name A and stick them together to get a symbolization for Socrates is human. Alternatively, I might take the predicate H and just stick the variable X and get X is human. Now, importantly note, X here doesn't name anything. It's a variable. So it's not actually telling us anything about X. It's kind of just like a way for us to say, hey, here's a labeled gap. We're going to figure out who to fill in a minute. And the same thing too, right? If we want to say woke up at 3:30, Mira woke up at 3:30, I can use the name for Mira, attach it to the predicate, and we're good to go. And here's the nice thing. If these are our replacement atoms, this plus a term, then we can, of course, use our various connectives, and they work just like they did before. That is, our new replacement atom can then be related with, say, conjunctions, or disjunctions, or the conditional, etc., etc., etc. Just the thing at the very base level now isn't a capital letter, it's going to be a capital letter and a lowercase letter. Always going to have those two together, at least. So I can say TM and TN for Mira and Nathan woke up at 3:30. Because someone was drunk coming home and Mira got up and started barking. Okay. So let's practice. Right. Let's use our sample symbolization key. It's the same one I gave you just a second ago. And we'll try a few examples. Here's our first one. Mira woke up at 3:30. How would we do that? Using this key.
DM.
How about Socrates is a terminator?
T1A.
Okay, nice, nice. Okay, so a couple nice, gentle beginnings. How about Nathan and Socrates are human?
HN conjunction HA.
And note, just like before, we can put the brackets on the outside or we can leave it. Either way is fine. The kind of sentence construction rules about conjunction run through just like from before. And how about our last one? If Mira woke up at 3:30, then Nathan woke up at 3:30.
TM, conditional TM.
Nice. Cool. Not terribly difficult, but it's useful just to kind of get a feel for this original kind of construction. Again, note, in every instance, what we're going to have is a predicate and a term. Capital letter and lowercase letter. That's the minimum. All right. So we got the beginnings. Now let's get to why this language is actually useful. Let's talk about quantifiers. There are two quantifiers, the upside down A and the backwards E. Let's take them one at a time. The upside down A is the universal quantifier. You will never have a quantifier that isn't next to a variable. I'll repeat that. You will never have a quantifier that isn't next to a variable. If you do not have a fucking sentence. You have junk. Right? Quantifiers always appear next to variables. The universal quantifier says for all or every. That variable that follows our quantifier is bound by it. What does that mean? That's basically saying, hey, this is the one that I'm attached to, and you can replace this variable. And the universal says you can replace this with everything. So a universal is going to be true if you can replace the associated variable with every object that you want to talk about. So if I said everything is human, right, that's going to be true if every single object that I could replace my X with is a human. Might be a problem if I plug in the table. So that's the function of the universal. It says, hey, you can replace this associated variable with every object. A nice way to think about it is it's a bit like a conjunction. It's a conjunction where you've taken, let's just look at our first one here, right? For all x, hx. This is roughly equivalent to A is an H, and B is an H, and C is an H, and D is an H, and you just keep going for every object. Just give a name for it and attach it to H. And of course, because this is a conjunction, what happens if even one isn't an H? What happens if even one of these conjuncts fail?
Then it's not valid?
Well, that's not that it's not valid, then it's just false,
Okay, false.
right? Because it's still just a sentence. So again, what does this say? This says everything is an H. So if you can find one thing that's not an H, no, it's not. Here's something that isn't an H. Now, right, this is the kind of basic formulation. We'll have a quantifier attached just to one predicate in a term. Or we might use quantifiers and relate it to more complex sentences. So this one says, hey, everything you can replace the Y with, let me put that in actual English. You can replace the Y with absolutely everything, and the sentence inside the brackets will be true. So this is equivalent to, cool, that for A, and that for B, and that for C, and that for D, and E, and for all of the names, for all the objects. Now let me again stress, it's not going to be all the names we have, it's going to be all the objects we have. We'll talk more about how to make these sentences true or false in 2 weeks' time, but it's just helpful to get a grip on what exactly they're trying to do. The universal says you can replace the associated variable with everything. there's our universal. Here's our existential. It says for some. Just like the universal, you will never see the existential without a variable. If you do, it's junk. It's always going to be attached to a variable. That variable will be bound. And what does the existential say? It says there's at least one thing you can replace this with. You can replace it with some name and get a true sentence. So, to go back a slide really quickly, if this says everything is human, right? The universal says everything is human. The existential says, hey, there's at least one thing that's human. And note, at least one allows for there being a shitload. It just says there's at least one. So it is more like saying or. It's not like there's a huge conjunction here. It's a huge disjunction. Either A is an H, or B is an H, or C is an H, or D, or E, or F, or no, until we've got through all the objects. So again, the nice thing here is if you find even one thing that's an H, the existential will be true. And much like with the universal, right, what we can do is we can use it for more complex sentences. So this existential in front just tells us, hey, there's at least one thing I can replace the Y with that will make this sentence inside the brackets true. I maybe don't know exactly which one it is, but I know there's at least one. So again, the core thing here, the universal says everybody, for all. The existential says for some, at least one. It's the use and ability to use these quantifiers that actually makes this language so useful. Because now we can talk about groups of things in one go. We don't have to have names for objects and just be able to pin them down. We can say things like, hey, everything that's a man is mortal. I can use my universal to say, for all x, if x is a man, then x must be mortal. Okay. Cool. Before we move on, what questions do we have? How are we feeling so far? Okay. Yeah.
We have a very simple question, but the universal and existential, are they always placed first in the sentence?
No. So no, they can be embedded too, right? So look at our universal here. The scope of this universal is just the antecedent.
Okay. But still there's an existential before that. If I remove that and would switch universal or an existential more to the back, is that also allowed?
That's perfectly fine. So, in fact, you can kind of see it here, right? So in this case, we've replaced the Y with a name. It's just the universal's embedded. Alternatively, you might have universal with the scope of the antecedent and the existential just scoped on the consequent. So we'll talk more about these as we kind of go, but yeah, they can have wide scope and control the whole sentence, or they can have narrow scope and just control sub-sentences. Just like every other operator. So here's the big trick to go ahead and let you in on the secret. The quantifiers are basically operators. They're not like the negation, the conditional, etc., in that they're truth functional. They're extension functional, which we'll talk about in a couple weeks. But I want to go ahead and say that. They're operators that instead of relying on sentences, lean on terms. Which makes sense, because they're always attached to these variables. Okay. More about that as we go. All right. So let's try and use some of the stuff we just talked about. And again, a little practice. Our same symbolization key And our opening sentence, everyone's human. How would we express this? How would we symbolize this using our key?
Antecedent H. H antecedent.
Not antecedent. The universal.
Oh, yeah.
Yeah. So the universal quantifier. And again, right, whenever we write the universal quantifier, it always has to be attached to a variable. So we could use X or Y or Z or U or V or whatever the hell we want. And then we would say, okay, that variable satisfies the predicate. Yes.
And is it true that you can put brackets on the H and the X?
Yes, that's perfectly fine. So you can put brackets in between the X and H and outside the X. You could put brackets if you really wanted to around the outside too. That's fine too. The only time we'll need brackets is much like before when we need to specify scope. So to go back a slide, we needed them here because it was making it clear that the scope of this is the whole conditional. Okay. Cool. So we did our first one. How about someone is human? How would we do someone is human?
Existential X and an HX.
Nice. Existential X to tell us this is the variable associated with the existential, and then that thing is human. There's at least one thing that's human. Somebody is human. Very cool. Okay. Here's our third one. There is a human, and Miro woke up at 3:30.
Existential X, conjunction M, no, VM.
Good. We skipped a part though. So it's the existential X, and then what's that attached to?
Bracket?
Close. So we don't want the existential just by itself. It's got to be always attached to these. So remember, at our base level, we always have to have a predicate and a term. So what's the first part going to be? It's going to be existential X and then HX. Right? It's telling us there is something, there is a human. So there's some X that's an H. There's some X that's an H. And then the other side is the one we did earlier. Sorry, this should be M. That's a typo. From older versions of the slides. Okay. Again, let's stress, why did it come out that way? So the existential is just a way for us to say there is, or for some, but we have to say, what's the for some like? If I just say, for some, I've not really uttered a complete sentence. I need to say something like, for some things, they're a horse. Or maybe to put this in better English, there's at least one horse. Or there's at least one person, one human. That's what we're doing here by sticking the two together. Okay? And how about our last one? If Socrates is a Terminator, then everyone is. If Socrates is a Terminator, then everyone is.
Universal X, brackets, D1A conditional D1X, brackets closed.
Nice, nice. So we can put the universal in the front and have it scope the whole quantifier. Here's something neat though. We can also just put it in the back. And that's just because really the only thing it cares about is that stuff in the back. But the one that you suggested would have been perfectly fine too. Nice. So again, note, what did we do here? We're always going to have a predicate plus a term. It might be a name or it might be a variable. If we have the variable, like the X, it's always going to be linked up with some quantifier. So the two basic rules. The thing that we fill in here, if it's a name, we're done. If it's a variable, then we're going to need a quantifier. And that quantifier is going to have to also be associated with that same variable. You can kind of see it in all of these, right? Every time we have a variable linked up with our predicates, there's always an associated quantifier which has that same variable attached to it. And that makes sense because the quantifiers tell us how we can replace the variable. The existential says, oh, there's at least one thing you could replace this with that will make it true. The universal says, fuck it, pick whatever you like. No matter what you plug in, it's going to come out true. But you always need to know which one is it that we're trying to say. Is it at least one, or is it everybody? Okay. So, before we move on, again, pause, ask what other questions do we have? How we feeling so far with the FOL stuff? Yeah.
It's also allowed to put the quantifier way in the back so that P1x is before.
No. So the way that our kind of grammar is set up, the quantifier will always be to the left of whatever it's going to bind. And I should also say too, this is just a kind of convention, but the way that we'll write things is we'll always put the predicate to the left and then the term to the right. Some other formal languages let you write terms on the other side, but this one we won't. We'll always just have predicate on the far left and relevant terms to the right. Okay. More on that at the very end of the lecture if we get to it. Okay. How are we feeling with FOL? Do we feel like we got the basic ideas? All right. Relatedly, how are people feeling? Do we want to take a break or shall we just keep going? Break is okay. Should we take a break? Is that okay with everybody? Okay. So we'll take a break until 43. 10 minutes.
Eerst moet je dan ook nog meer logische taal gaan krijgen. Uiteindelijk dat gewoon TFL als hele cursus. Ik vind het wel leuk. Ja, je kunt niet meer mee. Het ziet er wel cool uit. Zeg maar.
Als je mij niet ziet,
Ik kan het zien als we denken. Kun je nog wel daar.